Picking up from our last discussion on Descartes' dualism and its relationship with science, let's dive deeper into how he actually envisioned the practice of science during that transformative period. We're talking about the 17th century scientific revolution, a real shakeup. It wasn't just about new gadgets or fancy labs, it was fundamentally about how we think about knowing things. Thinkers like Descartes, Galileo, Bacon, Harvey, Boyle, Huygens, Newton, they were all in the thick of it, trying to figure out not only how to learn more about nature, but also what kind of knowledge we could actually claim to have. Now it's tempting to paint them all with the same brush, but that would be missing the nuance. They weren't all singing the same tune, and they certainly weren't all ditching the old ways in the exact same way. What they did share, though, was a common dissatisfaction with the dominant scholastic model of science. There was more agreement on what they were throwing out than on what they were putting in its place. And right in the middle of this intellectual upheaval stands Descartes, playing a crucial role in bridging the gap between the old, widely accepted scholastic view and the new, more empirical, hypothesis-driven approach that scientists were starting to embrace. Okay, so what exactly was this scholastic model that everyone seemed to be rejecting? Imagine the ideal scientific knowledge as described by Aristotle in his Posterior Analytics. It's got two key ingredients, certainty and universality. You know something scientifically if you know why it's true, and that truth applies everywhere, always. The gold standard for this kind of knowledge, pure mathematics. You start with definitions everyone agrees are true, then you logically deduce new truths from them. Since the logic is flawless, the conclusions must be just as certain as the starting points. This mathematical model heavily influenced the scholastic view of natural philosophy. Another big piece of the puzzle was the belief that our knowledge of the physical world ultimately comes from our senses. Everything we know, they argued, traces back to sensory experience. Nothing gets into the mind that wasn't first in the senses. Plus, they assumed God gave us reliable cognitive tools, so if we use them properly, we can trust our perceptions. Finally, there was the famous matter-form distinction. Think about dogs. They can be big or small, black or white, but they're still dogs. The essential dogness, the form, is what makes them dogs, while the varying features are just the matter. What we see in sensation is just the appearance of this underlying form. And since scholastic science aimed for necessary truth, the goal was to uncover these essential forms. So, explaining something meant finding the right form behind the appearances. It sounds neat, right? But many thinkers, including Descartes, felt this was holding back progress. Now, Descartes throws a wrench into this neat system right from the start, especially in his early work Le Monde. He basically says, hold on a second, can we really trust our senses as the ultimate source of scientific knowledge? His argument is pretty clever. He points out that just because we have an idea of something, like light, doesn't mean that idea looks anything like the actual object causing the light. He uses analogies we can all relate to. Words, for instance. Do the word cat look like a cat? Of course not. Yet words somehow manage to convey meaning and cause us to conceive of cats. Why then couldn't nature have set up a system where a certain physical process causes the sensation of light, even if that process itself bears no resemblance to our experience of light? He even uses Galileo's example, tickling a child with a feather. The child feels tickled, but does the idea of tickling resemble anything in the feather? Descartes argues there's no logical reason to believe so. If we can't assume that our sensations mirror reality, we've got a huge problem. We can't just look at how things appear and confidently say, that's how they are. There's a gap, an epistemic chasm, between our subjective experience and the objective world out there. This means we need a different strategy for science, one that doesn't rely on assuming resemblance. So if resemblance is out, what's left? Descartes suggests guesswork or hypothesis. Because we perceive secondary qualities like color, sound, taste, but not the primary qualities like size, shape, and motion of the objects themselves, we need to hypothesize what's causing those perceptions. Given his mind-body split, he assumes these causes must be material. But what kind of material? Here he starts building a basic physical theory. His core idea is remarkably simple. Maybe the size, shape, and motion of tiny particles are enough to explain everything we observe, including our sensations. It's a form of theoretical minimalism, trying to avoid unnecessary complexity. He even admits in Le Monde that choosing specific types of matter seems somewhat arbitrary initially. Once he has these basic assumptions, though, he often retreats into constructing hypothetical worlds, using fables to explore possibilities without getting bogged down in proving every single detail. It's like saying, let's imagine a world made of these kinds of particles and see what happens, even if we don't know for sure if our initial assumptions about their properties are exactly right. Fast forward about 12 years to the principles. Descartes becomes much more explicit about the hypothetical nature of his assumptions, especially regarding the specifics of particles. He lays it out clearly. Sure, if we know bodies are made of one kind of matter, infinitely divisible, but reason alone can't tell us how big these pieces are, how fast they move, or what shapes they have. God could have set up countless configurations. So how do we figure out which ones he actually chose? Experience, Descartes says. We're free to make any assumption we want about these details, as long as all the consequences of our assumption match up with what we observe through experience. Notice the crucial proviso, agreement with experience. This is a major shift. He's not claiming complete freedom. He's still arguing rigorously about the fundamental properties of matter, its primary qualities, and the laws governing motion. But when it comes to the specific values, the sizes, speeds, numbers of particles, reason hits a wall. We can only hypothesize and then test against experience. Why this focus on hypothesis and mechanical explanation? Part of it stems from Descartes' critique of the scholastic way of explaining things. He saw the scholastic reliance on forms and qualities as fundamentally non-explanatory. Take magnetism. The scholastics would say a magnet attracts iron because it has a magnetic form or quality. Well, yes, it does attract iron, so it has the power to attract iron. But that's just restating the phenomenon. It doesn't explain why it attracts. It's like saying sleeping pills work because they have a dormitive power. True, but useless for understanding. Descartes argued this approach was redundant too. Why introduce hundreds of different forms and qualities when Occam's razor tells us to keep things simple? And worse, these forms themselves needed explaining. It was pseudo-explanation. His alternative? Go back to basics, material and efficient causes. Explain things mechanically. How? By figuring out how the size, shape, and motion of tiny imperceptible particles combine to create the things we see and feel. For Descartes, true explanation means constructing a mechanical model of the underlying processes. But wait, how do we describe these tiny unobservable particles? We can't see them, touch them, measure them directly. Descartes' answer is models and analogies. We have to use things we can understand on a larger scale to represent what's happening at the microscopic level. Think of it like using billiard balls to represent light particles. He even claims this is the most appropriate way for the human mind to grasp physics. If an idea about nature can't be explained by some analogy, he suggests it's likely false. Now he's careful about what aspects of the analogy matter. When comparing, say, the motion of a tiny particle to a rolling ball, only the relevant features, direction, speed, shape, need to be compared, ignoring the vast difference in size. This leads to another interesting point. Are these hypotheses required to be true? Descartes surprisingly suggests that even plausible but incorrect models can be useful. He argues that imagining the world evolving gradually from chaos under natural laws is a better explanation than simply accepting divine creation, even if his evolutionary scenario is false. Why? Because it offers a more comprehensible mechanism. Similarly, he acknowledges practical limits. Maybe we'll never accurately measure all the variables at the micro level due to experimental difficulties. So we might have to settle for the best possible hypothesis, even if it's not perfectly accurate. So, how does this whole edifice of Cartesian science get built? Descartes insists on a top-down approach. Philosophy is like a tree, he says, with metaphysics as the roots and physics as the trunk. Physics depends on metaphysics. This is a stark contrast to modern science, where physicists often develop theories first and then figure out the metaphysical implications later. For Descartes, you gotta get your metaphysics straight before you can even start talking about physics. Where does this metaphysics come from? Not from complex experiments, which he distrusts as potentially misleading. Instead, it comes from reflecting on common sense, on everyday experiences, things like thinking, feeling, moving. He argues these are the simplest, most easily known starting points. By carefully analyzing these basic experiences using reason, he aims to establish indubitable foundations. Interestingly, despite his break with scholasticism, his metaphysics still uses some of their tools, like substance mode distinction, combined with metaphysical axioms like ex nihilo nihil fit and insights drawn from ordinary experience. This leads to his famous conclusions: the mind-body split, defining matter purely by its primary qualities and denying other properties like gravity or elasticity to matter. Once these metaphysical foundations are supposedly secure, Descartes moves on to formulate the laws of nature. These are presented as deductions from metaphysics, but the evidence supporting them is a mix. Take the law of inertia. Objects stay at rest or in uniform motion unless acted upon. This is partly justified by the metaphysical axiom that change requires a cause, and partly confirmed by observing projectiles. The other follow a similar pattern, blending philosophical reasoning with everyday observation. So, the completed foundation includes the mind-matter distinction, the definition of matter's primary qualities, the rejection of certain properties, the mechanical explanation model, and these three fundamental laws governing how particles interact and transfer motion. But here's the kicker. Having these general principles doesn't automatically tell you how specific things happen. As Descartes admits, there are infinitely many ways a particular effect could arise from these general laws. To figure out the actual mechanism, you need hypotheses and crucial experiments. These experiments help narrow down the possibilities and select the most plausible explanation among many that are consistent with the general laws. This brings us to a fascinating tension in Descartes' writings. His claims about certainty seem all over the place. Sometimes he speaks as if his scientific explanations are absolutely certain, demonstrably true, on par with mathematical proofs, or knowing that material things exist. Other times he concedes they're only probable, more or less certain, morally certain. How to make sense of this? Well, remember the historical context. Probability as a formal concept was still developing. The scholastics had a strict dichotomy: either you had demonstrated certain knowledge or you had mere opinion, nothing in between. Descartes, wanting to legitimize his new science, tried to fit the results of his method into this existing framework. So he makes a distinction. The foundational principles derived from metaphysics can achieve a high degree of certainty, perhaps even absolute certainty. But the specific explanations of phenomena, which rely heavily on observation and hypothesis, are inherently less certain. They're probable, confirmed by experience, but not demonstrably necessary like mathematical truths. He defends this plausibility by pointing out that his few principles explain a vast range of phenomena, suggesting they're likely correct. He also implicitly compares his system favorably to alternatives, which often involved infinitely complex explanations involving countless forms and qualities. Despite his philosophical skepticism about raw sensation, Descartes knew he couldn't escape experience entirely. As he explicitly states, observations become increasingly necessary as knowledge advances. He wasn't advocating for pure thought experiments detached from reality. However, he was a critical user of experience. He warns against naive, uncritical judgments based on spontaneous sensory input, the kind we form in childhood without reflection. What he values is reasoned judgment based on observation, honed by mature reason. This is why he famously says the intellect's reliability surpasses the senses, meaning reasoned conclusions based on experience are more trustworthy than unreflective ones. This commitment drives his practical philosophy, dedicating his life to acquiring reliable knowledge of nature through experimentation, aiming for useful rules, especially in medicine. He explicitly rejects philosophers who neglect experience and think truth springs solely from their own heads. So, while he's critical of naive empiricism, he embraces a disciplined, reasoned engagement with experimental evidence. So, wrapping up, Descartes is a fascinating figure caught in the throes of a massive intellectual transition. He embodies the shift from the old scholastic ways to the dawn of modern science. His key contributions: a firm commitment to mechanical explanation, ditching the vague occult powers of the past, and a crucial recognition that such explanations must be built on hypotheses. However, he didn't fully shed the scholastic habit of seeking a metaphysical foundation for knowledge, nor did he entirely abandon the quest for a high degree of certainty, even for scientific claims. He represents a bridge, a transitional figure grappling with the implications of a new way of understanding the world, acknowledging the limits of certainty while pushing forward with a method focused on hypothesis, experiment, and mechanical models. His legacy is complex, laying vital groundwork for modern science while still echoing the philosophical concerns of his predecessors.